Hi, everyone. So my name's Noah Harlan. I'm one of the founders of Tubules. We're a software development firm specializing in mobile and the infrastructure to support it. And we're going to talk a little bit about AllJoyn today, not surprisingly. And I think it's actually a really great segue to come right after Ivan and the Microsoft team, because what they were talking about, I think they laid a really good framework and foundation for approaching the software side of this. I think a lot of the earlier sessions were talking about OEMs and hardware manufacturers. I'm going to dip into that a little bit, but what Ivan and his team are doing is really exciting because they're making that first case for, okay, you're an OEM and you need to kind of bootstrap yourself into AllJoyn. They're making that really simple. And we kind of, I think what I'm going to talk about a little bit picks up from there. So where can you then take it? So developing interoperable IoT controls. Oh, that did some weird little curly cues. It's actually Noah Harlan and AllSeen Alliance. Not sure what happened there. So the IoT, we all pretty much know what that is. I'm not going to spend a lot of time dwelling on this. It's the world of all these objects when they connect. Network access means that objects can both communicate and be controlled. And the communication and the control aspects are both really important. So we talk a lot about the communication aspect, but when you have all of these devices, the control and how do you deal with interoperable controls is a real challenge. Because right now what we have is a huge number of companies that are bringing devices online, but the orchestration between them is difficult. And I'll talk a little bit about what AllJoyn's role in that is, and then what our role as software developers is. And these connected objects can really run a large gamut. So I was talking to someone earlier today, and they said, well, you know, where do you see the biggest adoption happening in the IoT space? And I think actually the biggest adoption that we see right today is a space that many of us aren't looking at, which is really industrial IoT. And that the home gets a lot of attention, but also that light commercial is going to be an area that'll go very, very quickly as those systems get retrofitted. And I think that you'll see the meeting point between kind of an industrial IoT and a residential IoT space propagating very quickly into light commercial and light industrial. So when we look at the landscape of what IoT is, we have our kind of IoT space with all the devices in it. And people are deploying lots and lots of devices. And those devices come from different manufacturers. Sometimes there's multiple devices from single manufacturers. And you have the OEMs over here who are doing all of this deployment. And they're starting to face pain points. Because once you start getting lots and lots of devices deployed out there, you need better systems for managing those devices, for managing the deployment, firmware updates, getting all of the data in, digesting that data. And what you're starting to see is platform as a service deployment management emerging as a real space. Not even starting to see, you've seen this for a while. And there's a lot of really interesting and exciting takes on the kind of platform as a service deployment management, helping people when they scale from that Kickstarter project where they've created one object that's deployed into the IoT space to suddenly having 100,000, to having 1 million, to suddenly having multiple categories of objects. That becomes a real headache. And there's people trying to solve that. You then have the second pain point, which is really what AllJoyn is all about, which is the interoperability between these devices, so getting devices to talk to each other and trying to break down some of the fiefdoms, as it were. And AllJoyn, as we've talked about all day and we will continue to talk about, is a standards protocol to resolve that. There are other ones, you know, we've heard from InOcean, which deals with that in a specific vertical. The guys from Carvoyant are here. They're dealing with that in a very specific vertical way. And there's other standards platforms out there. Qualcomm created AllJoyn as a standard communication protocol for IoT. And then in December of 2013, they open sourced it into the AllSeen Alliance. And AllJoyn is, this slide is actually out of date as of 2 days ago. It's no longer 122 members. It's now over 140. And it's the types of players that are involved with it are what make it so exciting and so powerful as a movement. It's not just dominated by one particular vertical. You've got white goods manufacturers, you've got small electronics manufacturers, you've got chip manufacturers, and then you've got this flurry of creative companies that have come around this, from individual device manufacturers to data services to software companies like us, who are all part of the alliance and all buying into the concept of what AllJoyn is. So a sample of some of the current protocols I'll join. IoTivity is another one. It's also in the Linux Foundation. It was put forward by Intel. It's quite a bit smaller. HomeKit will be another one. We don't really know all of the details of how they're rolling out HomeKit. But each one of these kind of becomes a framework of communication and standardization. So those are standards models approach. Admittedly, the last one is a specific OEM standard. You have OEM-specific communities of devices. So the reason why I put HomeKit under the standards is because they're not manufacturing the devices into it. Whereas Belkin with Wemo, Belkin's making the Wemo devices, and then they're allowing other people to connect to those devices. Google's Nest ecosystem, Philips Hue, those are big examples. And then you've got niche-specific. So I mentioned Carvoyant earlier that have a specific focus on automotive. Fitbit has a bit of an ecosystem that's really oriented around fitness. In Ocean, they talked about what they do, which is really very energy-focused and energy management-focused, energy harvesting. And each may have a place in the future, but in order to create a landscape that really stitches this all together, openness is the future. So devices are now talking to each other with these protocols, but the users are faced with this enormous problem of interfaces. They're acquiring devices, but onboarding and interacting is painful. And if onboarding is painful, and if interacting is painful, then utility is low, because all they're getting is the value of the individual devices in their individual silos. So if I like the Philips Hue bulbs, they're a lovely bulb. We prefer LifeX. We built the software for them. But let's say that I want a Philips Hue bulb. I don't want to, if you think about in your house right now, in your living room, who makes the bulbs? Most of you probably can't answer that. And most of the answers are going to be, it's a mix. You have some GE, maybe you have some you bought at IKEA, maybe you have some Philips, maybe you have some whatever. And the way we look at the home space and a lot of these spaces is that you're not going to see complete overhauls. So if I'm building a new house from scratch, okay, I have to buy all the bulbs for it. But when I look at my own house, I'm replacing bulbs over time. And then I'm going to replace them with things that are convenient, things that are appealing, but it's going to be a mishmash. And the result of that is user interface overload and confusion. So, I talked about this lighting problem. You have Philips app to control your Philips lights. You got a GE app to control your GE lights. You've got a LifeX app to control your LifeX lights. You've got these ecosystem challenges. So if you really like HomeKit, it's great, but they have to be iDevice certified. And then you potentially are starting to choose devices that'll work best based on what mobile you have at a certain moment in time. But the device you may be buying is something that may last you 15 years, a hot water heater, a dishwasher, a refrigerator. It seems silly that you should buy that device based on the mobile phone that you enjoy today. It ties you into an ecosystem and a set of decisions that may not reflect where the technology is in the future or where your individual preferences are. And then there's another problem, which is background. So these devices really gain a lot of utility when they can exist in the background. If they only work when they're foregrounded in some way, when you're explicitly controlling them, then you have a lower utility. When I get in my car in the garage and I turn it on, I want the garage door to open. I don't want to have to open an app to do that. So I want to be able to systematically or programmatically control the IoT space and control how these devices are organized, how they're responding to each other. I want some influence over that as a user. So this little blast from the past is kind of the problem that we're repeating. All the remotes. I think we all have that drawer of remotes that sits under the TV that controls the DVD and the cable box and the TV and the stereo system. And what we've done is we've gotten rid of the physical remotes, but we've replaced it with a wall of apps. And it's no better. In fact, in some ways, it's a little worse. So we view Higgins, what we created, as a way for it all to connect. And it's one of the ways that it can all connect. So Higgins is an interface with the Internet of Things. It translates your needs into orchestrated technical commands. It works across manufacturers and standards. It creates interoperability where none existed before. So one of the things that AllJoin allows, and that's really one of the beautiful things about it, is that I can have two devices that can communicate with each other, but they need to have no prior knowledge about how they communicate. I think Ivan actually no, it wasn't Ivan, but one of the team from Microsoft had a great quote. You did, where he said, "I don't want to have a phone call in order for me to interact with your light bulb as a developer." And that's really true, and that's what AllJoin enables. It can control all your lights at once. It can make things happen in the background because it also is not app-centric. It doesn't sit on a specific device. It can sit on multiple devices. So this, I think, is actually the crux of what I want to talk about, which is apps, the cloud, and the proximal network topology. And I think that this is the biggest thing for people to wrap their heads around when they start to think about the Internet of Things, and in particular about AllJoin and what AllJoin brings that's a little bit different. So the traditional model that we've come to understand over the last 30 years of computing is a very hub and spoke-like model. And actually that, I mean, we can geek out and go all the way back, kind of goes all the way back to the foundations of computing in some ways. But the API-driven structures, the RESTful APIs, are really this very hub and spoke model. Things have to call into each other, they have to have some method for authenticating and engaging, and then they have to get an explicit response. You also have then repeated that in many ways in the way that our mobile devices are interacting with the world around us. So by relying very heavily on web services, they've replicated much of the web service construct and conceit. But what AllJoin does is AllJoin is stitching things together purely in the M2M layer, purely in the machine-to-machine layer. So you create this thing, the proximal network topology, which is the lattice work of all of these devices as they sit within a given network, not out on the WAN, purely within their own LAN. So what does the proximal network topology bring that doesn't exist somewhere else? Well, latency for one. The most important thing, if you're a lighting controller, you have to be better than a light switch, because right now, a light switch works perfectly. If you think about it, if I have on my phone, I can, here's how a command can run to the lighting. It can go from my phone to my cell phone tower, to the central station for my cell service, if it's like DAS. Then it has to go from there to the internet, up to the cloud servers, AWS in Northern Virginia. Then it has to come back down through the network, come back to my home over Time Warner Cable in Brooklyn. Then it has to hit my router, which is not really that fast. It's not really that, high precision. It's not an industrial router. Then it has to find its way around the network, find the bulb, deliver the message to the bulb. That's latency. You know how the light switch works? There's a wire that goes from my wall to the bulb, and when you flick it, the power turns on, and it essentially works at close to the speed of light. That long loop that I just talked about, it may happen very fast, and it will happen faster and faster, but so long as there's a lag, that little bit of friction, it's like the little hiccup in the matrix. Every time you feel it, you kind of go, that's a little annoying. So for something like Nest, let's talk about the model that Nest uses. What Nest did, and what Google now does, is they create a state machine of your home. So they keep a model of your home in the cloud. And the model basically says, here's what the current temperature readout in your home is. Here's what it's set for. Here's the other information that thermostat has fed back to us. Here's what the smoke detectors have told us. And here, if you have the drop cam, however they're orchestrating that, that's a little more kludgy. And then if I want to change my Nest thermostat, so I have a Nest thermostat, I love Nest. When I lie in bed, my wife leans over to me and she goes, turn up the heat, because I like it cold and she likes it hot. So I pull out my phone, I launch my Nest app, and I turn it up 1 degree. And it goes up to the state machine, updates it, and then they use Firebase to shoot that command out. So it comes all the way back down through the wires, it hits my router, it hits the Nest, and then the Nest changes. So if I stand in front of my Nest when I'm doing that, there's a few seconds of lag. It doesn't matter. It's going to take an hour for my house to heat up. Well, hopefully not an hour to heat up 1 degree, but it takes a long time. So it's a low latency engagement. I'm totally fine with that. But if I want to turn on my lights, if I want a sound to play, if I want my door to unlock, if I want all of these type of immediate interactions, the more friction and latency, the more painful it is. and the more difficult it is for you to create a scenario that's better than a switch on the wall. So you may have all those features, and it's great that your light has lots of colors and dimming and programmatics, and you can have it respond to your music. But if it doesn't go on when you flip the switch, people are going to get frustrated. Scalability. So we've talked about how many devices there are. You know, the big T word comes out, trillions of devices. But think about the model right now in terms of consumer-facing products that exist out in the cloud. What they're generally looking at is the number of smart devices that you have. And as an individual, you have maybe 1, 2, maybe 3 smart devices. Maybe some of us are real geeks and we have a couple more than that. But you have your cell phone, your smartphone of some sort. You have a laptop, maybe you have a desktop. But the number of devices per individual is relatively low single digits. But when you start moving into the IoT space, the number of devices per individual goes up massively. It's all of the lights, it's all of the various equipment that's around you. So in a typical home, in the traditional model, you might have, you know, let's say a family of 4 might have 7 or 8 devices that need some sort of ongoing connection up. But that's now rapidly expanding to 70 or 80 devices. So the scale of what they're trying to connect with is huge. And let's once again look at the lighting challenge. In a typical home, you might have 100 light bulbs or more. You know, if it's a big house, you might have many more than that. I have an apartment, and I'm sure I have at least 100 bulbs scattered about that apartment. How many sockets does my router at home have, my Airport Express? You know, it could at most connect to about 50 devices, usually, most typical devices. Some are a little better, some are a little worse. But you're getting a relatively small number of devices that can connect. So you even have scalability issues inside the home. But then when you start thinking about what happens when it goes up to the cloud, if GE tried to connect to every light bulb that they had deployed on the planet right now, you'd be talking about connecting to millions and millions and millions of devices. And the slightest hiccup in your system in the cloud now is going to impact how all of those light bulbs potentially are working for people who are flipping switches on their walls. And that's a problem. So the latency comes back to haunt you when you combine it with scalability. The next thing is also not just scalability, but then you also have security questions, security and privacy. And Art is definitely going to talk about this with the gateway agent, and some others have talked about it. But the information that's being shared around your home or in your private space, your workspace, that information, you should have control over how that's moving into and out of that space. So why is it that all of those devices should be transiting all this information up and transiting it all back down? You know, one of the interesting things that AllJoin dealt with very early on was the onboarding experience for a light bulb. So the first light bulb connects to your Wi-Fi network, and then it tells the next light bulb, here's how to connect to the network, and then it tells the next one, and the next one, and the next one. But that means it needs to pass along credentials. So all of a sudden you have these very kind of low-power devices that have some pretty secure information that they're holding and that they're now passing along. And they're not using SSL inside the home. You know, that would be a very expensive proposition if every time they needed to connect to each other, they were using some version of like HTTPS. So you suddenly had a security exposure of anyone who could look at the packets on the local network could suddenly start to expose critical information that might be passing through the home. The other way to think about this, an example that I like to use, is IoT presents the world's most massively distributed computing environment. Each one of these light bulbs has a small processor in it. What could you do with a small processor if you had control of hundreds of millions of them? You could do a lot of things. You know, the world's craziest DDoS attack where the lights are suddenly attacking the servers. You could set up a bit mining operation where you had a little processor running on every one of these bulbs, and each one is mining. Each one's not doing much, but the thing is that you, as an individual in your home, would have no exposure to that. There's no process viewer for your light bulb. There'd be no indication aside from a slight rise in your energy usage that would probably be imperceptible. So there's a much more complicated threat matrix. And the more the communications are traveling and that information is being stored up in the cloud, the more that challenge propagates back into the IoT space. Persistence in environments is as important as passing between them as well. So when I leave an environment, I want to make sure that the things that I want to have happen in that environment can remain in that environment. So it's not enough to just have your control on a mobile device. There's something that needs to stay behind thinking. Otherwise, those actions that may need to take place in your environment in a low latency way are suddenly being brokered by the time it takes to find and contact your cell phone wherever you've traveled to. So for example, if one of your stories is that if the smoke alarm goes off, set the sprinklers going, I mean, that should be a very profound story for you. You don't want that being brokered by a service that it has to go out and have some latency with. That needs to stay within the proximal network. And I talked about this third point. So from our perspective, what Higgins does is Higgins sits within this proximal network and can get installed on any device that can accept an installation. So the demo that we have in the back, which we can show you, it's running on a Kindle Fire TV, an Amazon Fire TV, which is not an all-join device, but it brings all-join capabilities to that device. It can also run on an Android phone. You can run a WebOS version on an LG TV, and it can sit wherever is convenient. We were talking to the Gramophone guys. They're putting Gateway into their hubs that connect to the speakers that allow music streaming. Well, you could also put Higgins in there. The interfaces just become interfaces to Higgins wherever it sits within the network topology. So our approach to this is building scenes and making stories. It's a logical structure. So scenes are collections of devices in a specific state. So this room has a particular configuration. That's a scene, and I can capture that. Stories connect events to actions. AllJoin relies on this events and actions idea. So devices can either have events, which are essentially broadcasting what has happened, or they can have actions that they can take, which are things that you can tell it to take. What Higgins does is it allows you to program, okay, when I hear these things, then I want all these other things to happen. And Higgins monitors all the IoT activity, and it'll implement the user stories in the background. All right. Thanks, everyone.